Last unit of the year, ladies and gentlemen, and we are ending with volume. So the easiest one I think to do is the volume of either a rectangular prism or a cube, because you treat them the same way. And all you do for volume, if you look over here, is you are just multiplying the three different dimensions together. Length times width times height. So for example, in number 1, we can say the length is 9 centimeters. Well, it's kind of big, there we go. Is 9 centimeters times a 17 width, and it is 24 centimeters tall. Since we are multiplying, it technically does not matter in what order we do it because it is the same math operation. So if you called 17 your length, you still should get the same answer. When you multiply all numbers together, you should get 3,672. And here's what's important, centimeters cubed. Since you multiplied 3 different dimensions together, your exponent will be a 3. Let's give it another one. In number 2, I can say it is 10 inches long. It is, we can say 14 inches wide and 4.5 inches tall, right? And we would just do 10 times 14 times 4.5. Again, technically order will not matter. And you'll get 630 inches, again, cubed. I'm going to go ahead and leave number 3 for you because I do want to go into the other set. And this is for all other prisms. So for example, if we have a triangular base, if we have, I don't know, trapezoidal base, it doesn't matter. We'll follow the rule of area of the base times the height. Remember, height is between the space between the bases. The base is not always necessarily the shape the object is standing on. It is the shape that has a mirror image on the other side of the 3D figure, and these two shapes will never touch each other. So for example, in number 4, we have a prism, right? Area of the base times the height. Well, I'm going to have to say that the base, well, 3D figures are so fun to work with. Ooh, that is the bottom one, and I'll do the purple so you can see how it's oriented. Those are the two bases, right? They're both triangles and they're hovering over each other. Area of that base, so it's a triangle, right? So 1/2 base times the height of the triangle. The base of the triangle is 12, because that's where the 90-degree angle is happening, with the 7.3. Okay, that equals 43.8, and that's the area of just a single triangle. Now the height, I need the space that is between the two triangles. Well, the space that is between the two triangles is this 5 foot, so I'll times this by 5. Go ahead and plug that into the calculator. And when you multiply 43.8 by 5, you should get 219, in this case, feet cubed. Okay. I'm going to skip to number 6. In number 6, we have trapezoidal bases. All right, there's the trapezoid there in the front and trapezoid there on the back. So a lot of people are going to want to say that the base is a rectangle or a square, and it's not, because those are not identical shapes that are hovering over each other. So number 6, we have to find the area of one of these trapezoids. 1/2 height of the trapezoid itself, which is 17.9, times the addition of the two bases. Okay, after you do the PEMDAS, 447.5. Then again, what is the distance between the two trapezoids? Well, it's right here, the 25. So times by 25, ooh. Let's try that again. times by 25, 11,187.5 meters cubed. So on this page, you're responsible for questions 3 and 5, okay? On the next page, I'm just going to help you guys out by identifying your bases. Here you've got two triangles, identical shapes that are not touching each other. And then here on this one, hard to see, but again, these are two trapezoids, okay? I'm going to draw the trapezoid, I'm going to rotate it, and on its own, ooh, I'm not an artist, we all know that. This is 25, this is 39.4. I'm just going to tell you guys right now because we're going to need the missing side of the trapezoid. You're going to need to know the Pythagorean theorem, right? So, because of that, right? So I just want to help you guys out that, in case you can't clearly see the trapezoid there. Okay, volume of cylinder, super simple, because half of this formula we've done before, pi r squared, area of the circle, right? Pi times 18 squared. That is nothing new. The only thing we're adding is how tall is the cylinder. Well, we're multiplying it by the height of the cylinder, which in this case it is 15. So do your area of a circle, times it by 15. You'll get 15,268.14 inches squared. That's all you're doing here, finding the area of the circle. Pi. 11 is your diameter, which means 5.5 is your radius, times the height of the cylinder, 21. 5.5 squared times pi times 21. All that needs to be plugged into a calculator. 1,995.7 meters cubed. These two application problems I'm going to leave for you. The pictures for each question are drawn to the left of the question, so please refer back to that question and let me know if you guys need any help.